Imagine waking up and finding California's famous shoreline perched 6 feet higher than it was the day before. From San Francisco to Los Angeles, beaches sit stranded above the waves, harbors are suddenly too shallow for ships, tide pools bake in the sun, and every instrument, from NASA JPL satellites to humble municipal GPS bolts in concrete, agrees on the unthinkable. The land leapt in hours, not millennia. No earthquake, no volcanic roar, no warning. Just a silent, simultaneous rise that defies a century of measurements and everything textbooks insist is possible. Geologists argue over data and physics. One fact refuses to budge: the uplift has not stopped. Along the edge where the Pacific and North American plates duel, motion is normally a whisper. Vertical change on this coast is measured in millimeters per year, not feet per night. Tiny drifts etched by subduction far offshore, sediment compaction under cities, or human tinkering like groundwater withdrawal in oil fields breathing in and out. In places such as the Santa Barbara Basin, carefully calibrated instruments have long tracked uplift of 2 or 3 millimeters a year. Long Beach has seen human-driven subsidence and rebound on the order of centimeters, always slow, always explainable. Tide gauges, GPS arrays, and INSAR radar agree on this rhythm. It's the baseline scientists trust, which is why the first reports of 6 feet of vertical. The jump detonated through the monitoring world like a siren. These networks are built to catch the tiniest twitch. JPL systems routinely resolve shifts thinner than a fingernail. Their data are cross-checked by independent satellites, ground stations, and tide markers, each one a skeptic, insisting on proof. Yet, before dawn, stations up and down the coast logged the same impossible step. Tide gauges recorded a mirrored drop in relative sea level. INSAR scenes processed by separate teams reproduced the jump in crisp, unbroken swaths. Leveling surveys on the ground matched the satellites overhead. One scientist put it bluntly: if the numbers are right, we aren't just revising a chapter, we're questioning the ground beneath our feet. An audit began at JPL, measured in seconds and sleepless nights. Raw Rhinex files were pulled from every GPS station that flagged the leap, with teams checking antenna models, monument histories, and even the soil beneath each concrete pier. They hunted for a ghost in the International Terrestrial Reference Frame, the kind of subtle coordinate hiccup that can fake a rise on paper. They poured through tropospheric and ionospheric corrections, hoping a solar flare or violent storm had warped the signals. They tested for multipath reflections, GPS echoes off buildings and water that can trick receivers, then turned to the bugbear of radar, phase unwrapping mistakes that can transform a gentle slope into a vertical cliff. One by one, the usual suspects fell away. The INSAR fringes were clean and coherent. The uplift band ran like a ruler across bluffs, suburbs, farmland, and rock. The GPS time series rose in lockstep. Tide gauges corroborated the land's new height relative to the sea. Redundancy, the golden rule of geodesy, was satisfied. The signal refused to break. With every cross-check that held, the choices narrowed to 2 unsettling possibilities. Either the world's most sophisticated monitoring architecture had failed everywhere at once in the same way, or something had happened to the crust that no one knows how to model. Engineers scribbled frame slip, multipath, unwrap, and crossed each out. The uplift remained, a neat, continuous step where there should have been none. History offers its own cautionary tales, though on smaller canvases. In Portuguese Bend, south of Los Angeles, a mid-century landslide turned neighborhoods into a slow conveyor belt. After the punishing winters from 2022 to 2023, rain soaked deep clays and reawakened older, deeper slide plains. Instruments clocked movements up to 30 centimeters per week, and the active zone swelled from approximately 380 to 700 plus acres. At a landslide's toe, the bulldozer front where soft masses slam into harder coastal rock, compression can bulge the ground upward. Field teams mapped domes and fractures with GNSS and INSAR, watching not just lateral creep but a vertical pulse as the slide's front jammed and buckled. That kind of uplift needs no quake, just water, gravity, and stubborn geometry. But even that dramatic physics is local. It cannot explain a ruler-straight rise from San Francisco to Los Angeles. Out on the waterfront, the human consequences arrived. Faster than explanations. Los Angeles and Long Beach harbor masters stared at stranded container ships resting on mudflats where deep water channels used to be. Cranes stood idle. Radios crackled with reports of fishing boats perched high and dry. By midday, America's busiest ports were effectively severed from the Pacific. More than $1.4 billion in daily trade began to hemorrhage. Perishable cargo stalled, supply chains buckled. Up the coast, Monterey, Port Hueneme, Oakland, the story rhymed, docks marooned, schedules shredded. On the beaches, the ecological cost was harsher. Tide pools that once harbored starfish, anemones, and crabs were lifted beyond the ocean's reach. Rescue teams raced with buckets and wet towels, but for every animal saved, dozens more succumbed in the heat. Then the data war went public. A Silicon Valley firm, GeoStride, released independent satellite analytics confirming the 6-foot step with sharper spatial detail than some government products. The USGS countered within hours, warning that satellite-only solutions can be fooled by the atmosphere and by processing choices. GeoStride accused federal networks of clinging to aging ground hardware. Leaked emails showed scientists on both sides scrambling to defend reputations while FOIA requests piled up in inboxes. Rumors bloomed, classified tests, secret drilling, stray detonations. The Department of Defense denied and the speculation kept breeding. Insurers, already staring at a maritime catastrophe, watched claims spike by billions and discovered force majeure clauses they hoped they would never use. Was this an earthquake without seismic waves? A landslide without a slope? Or a failure of the instruments designed to keep reality honest? By nightfall, a grim summary took shape. GPS and INSAR confirmed up to 6 feet of vertical land change along 400-plus miles of coast. Sensor malfunctions were unlikely given the cross-validated audits. The uplift pattern matched no known earthquake, volcanic swelling, or regional landslide process. Portuguese Bend proved rapid, local uplift is possible, but nothing in the literature accounts for the present scale and uniformity. Official reports from public agencies and private firms conflicted. Key datasets were still under internal review or classified. Ports sat idle. Marine rescuers worked flat out. California faced an unprecedented crisis with no agreed-upon cause. For now, the phenomenon was unexplained, and the question of whether the coast would keep rising hung over millions like a tide that no longer obeyed the moon. Meanwhile, half a world away, Mount Etna offered a different kind of riddle. The volcano famous for never truly sleeping suddenly produced lava so unusual that 3 top European labs could not classify it, neither basalt nor andesite as we have known them. As incandescent rock spilled from the summit, a pyroclastic flow pulsed down a flank, and deep seismic signals hinted that the mountain's internal scaffolding might be shifting. Echoes of conditions that preceded ancient sector collapses and a prehistoric tsunami. Etna has erupted in some form for more than 3,500 years of recorded and archaeological time, with dozens of episodes in the last century alone, ranging from the violent spectacles of 2001 to 2002 to quiet dome building phases that reshaped the summit like a living thing. Petrologists have mapped its magma system as a tiered architecture, a deep reservoir around approximately 10 to 11 kilometers feeding mid-crustal way stations where fresh melts mix with older batches, their minerals, olivine, clinopyroxene, plagioclase, locking in chemical fingerprints as they rise. Over 50 years, analysts have tracked a gentle enrichment in potassium and strontium. likely from crustal assimilation. Through it all, Etna's lavas have sung a familiar tune until now. What does a coastline that rises without a quake have in common with a volcano? Extruding a rock we can't name? Perhaps nothing. Perhaps everything. It may be coincidence, the Earth's complexity throwing two puzzles at once. Or it may be a reminder that our instruments, powerful as they are, measure more than we yet understand. The task ahead is brutally simple and scientifically hard. Verify the signals, map the physics, and separate anomaly from artifact. Until then, the Pacific's busiest ports sit marooned, tide pools crackle under the sun, and a Sicilian giant breathes out a chemistry that won't fit our shelves. If this isn't a warning, it is at least a question. Not just what happened, but how sure are we of what can't happen? Because today, the shoreline moved without a sound, and the mountain changed its voice.